Mustafa.com or Amazon.com. Okay. So in that e-commerce, so you write the code, you develop a front-end application, back-end application, APIs, etc., etc. Everything is ready. Okay. So all the codes, okay, it's there in your laptop or system or in any device. Okay. Then you plan to go for the public. Okay. What all the things you need when you are going for the public? The first thing is you need an address. Okay, address in the sense of IP address. Okay. So if you want to reach to someone's your friend's home or something, you need an address. Okay, the same thing when public need to reach you, your system, your application, then that particular things we need an address. Okay, so you will go to your ISP, okay, and you will have some public IP address. It's a static IP address. Okay, it should not change. Okay, so you will get some IP address. It will cost like for 45 rupees Indian currency, 45 to 50 rupees per month. Okay, if you are in US, it will take a $1 or $2. Okay, then okay, now you have IP address. Okay, so that IP address, then you need a domain name. Why we need the domain name? Okay, for example, we all know, like if I ask you to list out what are the websites you know so far, you can list out like a 50 to 100 websites. For example, Google, YouTube, Instagram, Flipkart, Amazon, etc., etc. You can list out like a 50 to 100 websites. Okay, we can easily memorize those websites. But if I say this name should not be the name or only with the IP address. Okay, there is a no name. Okay, only the IP address. In that case, we cannot able to memorize that because, for example, Flipkart, the IP address is like 50.60.70.80 and Amazon.70.80.90.100. So everything will be in the numerical format. Then we cannot easily remember that. Correct. So that is the reason we save the phone numbers and the address into the something name and all. Okay. Eshwara's phone number, Mustafa phone number, something like that. So the same thing. Okay. We cannot able to memorize our IP address. Okay. So we need to convert that IP address into some name. Okay, so that is called domain name. Okay, so same like a youtube.com, google.com. Okay, so this google.com and all just a name. Okay, behind that there isn't some address is mapped to that domain name. Okay, for example, if you go for let me show you. So if you go to command prompt, okay, I'll go ns lookup. Okay, if I type google.com, this is their original IP address. Okay, 142.251.222.174. This is their actual IP address. This is the actual address. Okay, so instead of memorizing this, Google convert this into the some name that is called a google.com. The same thing will apply for the any website. If you go for youtube.com, there's the same web, something like the same IP address. Okay, so you need some domain name, okay, for your application. Okay, now your application, okay, it's the same thing. You will go to your ISP or some third-party websites like the GoDaddy.com, Wix.com. So to get an IP address. Okay, now sorry, now you get the domain name. Now you got a domain name like something like a Mustafa.com. Okay, so the Mustafa.com is your e-commerce platform. Your IP address is something like a 8.8.8.8. Okay, so you need to map. Okay, so that is called an app translation. That's all happen in the domain name controller. That means that same website itself.
Yeah, in the DNS.
Okay,
the DNS does
correct.
the translation.
Okay,
Yeah.
So this is now the domain name is completed. Okay, so domain name is completed, public IP address completed. Okay, so now you need to do the some NAT translation, some basic configuration in your router. So if it's done, okay, so whenever the public is accessing your Mustafa.com websites, that will land into the your computer. Okay, so now that website is working. Okay, so if someone is from the public, you're trying to access, the application is working now. Okay, so then what you need to know? So then you will develop your application. So automatically, initially your friends and families will use your application. Then you will approach some sellers, okay, to sell their products in your platform. So automatically sellers will come, automatically buyers will increase. So friends and family too, it will go to your state level. Okay, from the state level, okay, inside the state level, for example, normal, you will have some basic connectivity. For example, uh, few users per second. Okay, now you, whenever your application will develop, okay, it will turn into the few thousands of users per second. Okay, when the users is increased, your laptop or your system will not handle such utilization. Okay, when automatically the users increase, you need to upgrade your machine as well. Okay, so your laptop or your system will not capable of handling those user requests. So you need to increase your that means a specification. For example, that is the two things. One, you will convert your laptop into the server. Okay, the server is nothing but this is also the system, but it will have a high CPU, high threads, high RAM, high memory, everything. Okay, it's just some dedicated for the application support. So you, it will increase to the server. Sorry, it will change it to the servers. Now the server will capable of handling those requests. Again, your application will develop somewhere. Okay, few thousands of requests will increase into the few lakhs of requests. Then again, that particular server is not capable of handling that. So automatically, if your user has been increased, then automatically you will get some money. So you need to go for the office space. Okay, so you will hire some software engineers, you will hire some database engineers, you will hire some storage, etc., etc., all the team HR, etc., etc. So whenever you develop as a company, then again some other application you need, like for inside the office, you need a office applications like Office 365, HR application, attendance, etc., etc. So that's all you needed. Okay, so as your main application, then you need a some office application, then you need a test environment. So it automatically increase your multiple servers. So you need a office space. So you will go to some office space. Okay, for example, you will rent over some building. Okay, inside the building, you will have some room for the server configuration. That means the server rack. Okay, so inside the server rack, what will happen? 1 second. So inside the server rack, okay, for example, this is your room. Okay, this is your office space. Okay, inside the office space, you will have some room for the server. Okay, what we have in this room. Okay, so automatically you will have some router.
Yes.
Why we need the routers? The routers is a key component to get the internet from your ISP. Okay, so the next one is you will have a switches. Switches is for broadcasting. I will explain. Okay, then after the switch, you will have a different servers. Okay, all servers you have. Okay, again, if your application will increase in the users, okay, it will have some crores of users, it will have some worldwide customers. Okay, automatically what will happen, the small server room is not enough, then you need to go for some data center setup. Data center setup means you need to rent out some large space. Okay, inside the large space you will have a all the features, like you will have a router, you will have a firewall, security devices, etc., etc. That is a lots and lots of you need to invest because you are running a digital platform. Okay, so security, digital security is a more important to you, so you need to buy so much product. Okay, so Now you have some data center setup. Okay, your company will go automatically is growth like Amazon, Flipkart, etc. Okay, or you have a data centers. Okay, you will earn some good amount of money. Everything is fine. So next, what we need to do? Next one is we need to provide the redundancy. What is called a redundancy? Okay, so it's a 24/7 your application need to run. Okay, for example, I can say, okay, you are running a Mustafa.com, right? It's an e-commerce platform. So many users is there. Okay, so users need to buy some products at any time. Okay, it should be morning 3 a.m. or evening 3 p.m. or 12 a.m. anytime. Okay, so that application should reachable all the time. Okay, if something is happening to your application, for example, your routers come down or your ISP having some issue or your server having some issue, anything can happen, right? So in case if something has happened to this any of this flow, okay, ISP to router to switch to servers, anything happen, firewall, any other device you can say. So automatically what will happen? It will affect your application. Okay, if it's application, if for example, if I'm searching, if I'm working, that means if I'm looking some products in the Mustafa.com, okay, so in meantime, okay, it's down. Okay, what I'll do? I'll directly go for the Amazon. Okay, so you are losing your customers. Okay, if repeatedly happen the same time, if repeatedly your application will go down for some time or sometime from some time, okay, what will happen? Automatically, I will go to the next product, next platform, Amazon or Flipkart. I will not use the Mustafa.com. I will think like it's always down. So I will directly go for the another platform. Correct. So so we need to give the redundancy. We need to give the 24/7 the application should reach. How does it happen? Okay, by using the HA mode. That means a primary. We have one primary and we have one secondary. So instead of using one routers, we need to use a two routers. Instead of using one ISP, we need to use a two ISP. So every company will have at least this setup. Okay. For example, if you are using the AT&T as your primary, okay, if AT&T down, I need a backup as a Verizon. Okay, the AT&T router is connected. AT&T connection is connected to one router. Verizon is connected to another router. If that particular router one fails, the router two need to take care of the traffic. The same like every devices having the primary and backup setup inside the same data center. Okay, so if the any of the primary devices fail, automatically the backup will active and backup will serve the traffic. So it will have some backup. Number one. Okay, so now we have in the same data centers. For example, your data center is in San Francisco. There is some overall power outage in the whole San Francisco city, or there is some earthquake, or there is some natural disasters. What will happen? Your data center is completely down. Okay, then what will do? So you need to have a secondary data centers. Okay, so the primary router, primary router, secondary routers, which is in the same data center. So the same as like a same data centers, we need to have a secondary data center as well. Okay, if it's for example, one is in San Francisco, one is in like a Washington. So different geographical location, or else in different countries. For example, one is in US and one is in Europe, or one is in US, one is in India. So the different geographical location. So if something is happened to your one of your data center, the secondary data center will take care. Okay. The secondary data center also same like a same setup. Primary is also there, secondary is router, primary router is also there, secondary router is also there. Primary ISP is also there, secondary ISP also there. So your application instead of one particular flow, you will have a 4 flows. Okay. Inside the primary data centers, you have a primary and secondary. If both fails, then it will go to the secondary data center. In the secondary data center also, we have a primary connection, secondary connection. Okay. So if the 4 connections will fail at the same time, then only your application will go down. So that is a hypothetical situation, right? So that is a very rare. Okay. So this is how we develop our company, develop our data centers. Okay, our network will develop. Okay, now we have a full-fledged data center setup. Wherever you go for the company-wise, if it's something like a MNC or like a good name company, then they definitely follow these setups only. Okay, they will have a at least two data centers. Okay, one is a primary and one is a secondary. And every data center they have a primary devices and secondary devices. If you think like Amazon, they have a data centers in the whole world. Okay, so they have a multiple data centers in US, Europe, in India itself. There is a two data centers. One is in Mumbai and one is in Hyderabad. China also we have two or three data centers. Singapore we have data centers. So any data centers space, okay, normally we can get the connection from our nearby data center. For example, if I'm trying to access some Amazon service, I will get the data from the Mumbai data center, Hyderabad data center. Okay. If Mumbai fails, I will get that from the Hyderabad. Hyderabad fails Mumbai. So if both Mumbai and Hyderabad fails, I will get the some other data center. So they will have for the user experience, they have a different data centers in the all over the world. So this is how the data center, the connection for how what to say, like a company will grow. Okay. So any doubt so far?
No, no. I actually already did the like CompTIA basics, so I had idea for this already, like how cloud, uh, how how company will have data, how company will have like backups for data centers with regards to keeping their practice. So I had some idea with this, so no doubts over here.
Okay. So the second thing is how the users is reaching your application. So you are running your application inside your data center. Okay. So how the user is reaching your application. Okay, for example, your data center is in San Francisco. Okay, I am accessing your application inside my home. Okay, for example, I'm in Chennai, India. Okay, so I will use my router. Okay, I have a connection with a Geo. Okay, so from my mobile to your data center, how the connection will flow? Any idea, or I can explain?
So, how the data will flow? Meaning, are you asking the physical medium of how it will flow, or
Yeah, it's a physical medium. I'm asking like so from my mobile to your data center, how what are the connections if we have? Okay, let me explain. If you know, you can just recall that. Okay, so from my home, okay, I will access some in my mobile browser. I am trying to access some Mustafa.com. Okay, once I enter Mustafa.com, okay, it will go to my router because I'm connected via Wi-Fi or any other mobile data or something. So it will go to my ISP. Okay, from ISP, the DNS resolve will happen. Okay, so the connection will go to the DNS repository. Okay, inside the DNS repository, it will check for the what is the actual IP address of this Mustafa.com. Okay, so when you are buy some domain name like a Mustafa.com is a map to the 8.8.8.8. Okay, so it will resolve to the actual IP address. So now my ISP router will have a actual IP address which is 8.8.8.8. The second thing is it will look for who is owning the IP address. Okay. So first of all, who is managing this IP address and all? Okay. We have some organization called INA. IANA. Okay, so this INA is a organization which is handling the IP address and this all the networking, telecommunications, etc. for the worldwide. Okay, so this INA, the very first time that whenever they are inventing this IP address and all, so they give some range of IP address to the different countries and something. Okay, so for example, I can say from 1.1.1.1 to 10.10.10.10. Oh, sorry, that is a private IP address, right? So 9.9.9.9 to up to US can use like that. Okay, I will just tell the example, not exactly. So same like India also have some organization called TROI, okay, Telecommunication Regulatory Authority of Regulatory Authority of India. Okay, the same range will get something in the India as well. For example, 11.2 15 for India will get 11 to 15 IP address range, I can say. So whenever I am developing some ISP company, Geo is there, Airtel is there, Flipkart, sorry, Vodafone, Idea, something like that. If I'm creating some company, I will get approval from this TRI. So the TRI will give some, okay, so you are having some around thousands of a few lakhs of users, so you can use this particular range. Okay, from 11 to 15, in between there is some range it will give to myself, that may for my company. So from that range, I will give to the customer. Okay, the same thing the US is also follow. Okay, if you are, for example, you are using the Verizon to your network. Okay, so the Verizon will have some range. So my ISP will find out who is owning the IP address. It will come to know. Okay, so this is someone. The Verizon is owning that. Okay, it is in US range. So I need to forward the traffic to the somewhere in US. Okay, so from India to US, so all the overseas communication will happen via Tata Communication Company. Okay, so 80% of connection will go through the Tata Communication. Remaining few is there in a Geo or something. So most of the communication will go via Tata Communication. So it will forward the communication to Tata Communication. Then Tata Communication it will go to the US. So in between there is some pit stop like so it will go to the Dubai or Singapore or some other countries. From there it will go to the US region. You know that overlay cables under the that means we have a cables network inside the ocean and all, right? So there is a huge cables we lay or in the layer of the ocean. So from that layer, from that wire, it will reach to the US. Okay, US also may have some AT&T to Verizon. So Verizon completely look for okay where we give in this IP, so it will go to the San Francisco. From the San Francisco to it will go to your data center. So from at last it will reach to your router. So this is how ISP will ISP play the role into your connection. Okay. So now once it will reach to your router, then it need to go to your server because the server only runs application. Server only have a code. Okay. From the router to it will go to the server. Okay. So there is some other devices involved inside the data centers, connection involved. So that is the thing we are going to study so far. That means in the upcoming classes and all. So this is the ISP role. Okay. So now we know how to develop an application through the network, how to reach the application from the public side, and third one is what is the role of the network engineer. Okay, network or network security engineer. Okay, so the role is there's a two part. Okay, one is the network engineer who is working for the some company, then that means a client side. Okay, so if I am working for as a network engineer in the Mustafa company, okay, my role is to handle the configuration and other all the activity inside the data center. Okay, if I am working as a network engineer for Verizon or Geo or any other ISP, my role is to take care of the traffic between this different communication. Okay, so there is a two role is there. Okay, one is for the ISP engineers, and one is the that one company based network engineers. Okay, both work is kind of same, but not 100% same. Okay, so ISP engineers will predominantly work in something like a WAN connection. That means the internet connections. So as a company network engineers, you need to work mostly into the LAN connection inside your company. Okay, so this is the difference between the ISP engineers and the company engineer. Okay, so now you hire the network engineers, everything will set up, everything is set up. So now, okay, this is basics of the networking before we need to step into the syllabus and all. Okay, so far any doubts?
So, what you're telling with regards to this network engineer roles is
Mhm.
one person is providing encapsulation to what exactly? Can you repeat that?
Okay, we have a two types of network engineers. Okay, one who is work for the ISP. Okay, he may work for the
For example,
Geo,
okay,
Airtel,
okay.
Verizon, AT&T kind of things. Okay, so they are mostly works for the WAN connection. WAN connection in the sense of internet. Okay, for example, they need to establish a connection between the whole internet, like some different application, different. So internet in the sense of you can take anything, Google, YouTube, etc., etc. A to Z, all the websites will work under the internet only. Okay, so their work is completely for the internet. Okay, as a company networking engineer, if I am work for the Mustafa company. Okay, I will handle the Mustafa's data centers only. Okay, inside the data centers they have a routers, firewalls, IPS and IDS. That means that different security devices, different communication devices, servers, cloud, if needed. So this all comes under the one company. So I will work for the company. Okay. Now you can take like in my previous company, I work for the westernunion.com. So you know the Western Union is a money transfer application. They have four data centers. So for the four data centers, all the devices, all the communication, we are the responsible. But ISP, they are also going to work on the same technology. So whatever you are doing inside the companies, they are also doing the same thing, configuration, etc., etc. They are also going to handle the routers. They are also going to handle the firewalls, etc. But the work we have and the ISP engineers have, it's a little bit different. Okay, so that is the difference. Got it?
Okay, so basically you're saying companies like Verizon, Geo, which provide internet, they are operating on bigger networks like WAN, and one engineer is working on the wide area network, and there are other
Correct.
companies that are doing what exactly? There are other companies.
Okay, so these other companies in the sense of it's not an ISP. Okay, you can take like a westernunion.com, Comcast, TCS, Infosys, any other companies. Okay, so the network engineers in that particular companies, they are working for the LAN, but LAN in the sense of inside the company network. Okay, for example, I can say TCS.
Yeah,
Okay,
basically
TCS
they
we
are
have a
managing.
different.
Yeah, they are managing the internal network of the company. Is what you're saying, right?
Correct.
Okay, okay. So one is basically for wider network, other is for the internal network.
Correct.
Yeah, that's it.
Okay. It's not only for internal. Okay, they are also having some communication with this WAN, but the workload is different. For example, ISP engineers will completely 95% of work will be the WAN, 5% will be the internal. But here, 95% will be the internal, 5% will be the WAN. That's
Okay,
all.
okay, got it.
Okay, so why I am saying this? Okay, see, the thing is different. Okay, so someone will be interested in the van, someone will be interested in the LAN. So if you are interested in van, for example, HD van or different technologies there. So if you are good in that particular technology, you can look for the role in the ISP side. For example, Lumen, AT&T, Verizon, etc. And that companies. If you are good in internal, that means internal configuration, you can look for the some other roles. Okay, so that's a different. Okay,
Okay.
so this is the thing. Okay, so now everything will set up. Okay, we know what is a redundancy, application is working fine, everything is there. Okay, so now what we have inside our data centers, what are the devices we have? Okay, so now we are stepping into the syllabus. Number one. So, what are the devices in the sense of, okay, the first one is routers. Okay, any idea about what is routers? Why we need the router?
Router will actually use to connect one network to another.
Correct. So router is a device which act like an intermediator or it's a communicator between the two different networks. Okay. These two different networks means like say it's my company is Western Union. I need to connect to my ISP which is Verizon. So Verizon is a different network. Western Union is a different network. So when communicating to these two companies, I need a routers in between us. Okay. So Verizon is sending the connection to the routers. So the router will establish a connection to my internal network. So this is a simple. So what is the disadvantage of the router here? So disadvantage of the router is mainly okay. Again, we have two major devices. One is routers and one is switch. Okay, and what is switch? Any idea? Why we need the switch?
Switch is basically a device using which uh, the packets can be forwarded between host in a network.
Okay. Uh,
Basically, an extension cord for the network, because router
exactly.
will give less number of ports, so we'll have minimal
Exactly.
device.
Correct. So, uh, there is some concept called we have a symposium cafe and like in 2005 now we have everyone we have internet and all. So before that 2005 and all, we have some browsing cafe, right? So how the browsing cafe we have? Okay. So
Your
yeah,
voice
they
is
will have
breaking
some.
actually. Your voice is breaking, sorry.
Okay. I think it's from university because we were the student for all the world. Uh, it,
Yeah, my speed is 200 now. Let me just leave and join again.
so not only so every we go to this system. So, but it's not optimal. It's the
Yeah,
right way because
it's
you
not.
know,
It's still the same actually.
people online actually.
Uh, can you join this meeting? Can you join this meeting? Hello? Hello? I cannot hear. Can you join this meeting? I just shared you the link.
Okay, is it audible?
Yeah, it's very clear.
Oh, okay. Fine.
I cannot see a screen though.
One second. One second. Enter screen.
Bottom, that arrow will be there, which points up.
Now it's, I'm sure. Is visible now?
No. Yeah, it's coming up.
Okay. Okay. So if you take a router, okay, so routers, we have a limited number of ports. Okay. So in this scenario, there is a two option. One is you can buy a multiple routers for every single device. You can give the single router. Okay. But
Yeah, so
what is the disadvantage?
I couldn't hear when when you started drawing the diagram, all your voice went away. So I don't know what you're talking about here.
Okay.
Yeah, you can continue the same. I just
Okay. So if you give the dedicated routers to every single say every single system, what will happen? So you need to maintain the multiple routers. Okay, you need to recharge, you need to manage everything into that multiple times. So that is not an optimistic way, right? So that is the reason. Okay, so the routers is for the different networks, fine. Okay, but since we have a limited number of ports, okay, you need a another device called switch. Okay, the switch will broadcast, which will act as a bridge between the routers and endpoint devices. We have a n ports should be high. Like we have a 4-port switch, 8-port, 12-port, 24, 48. Up to 48 we have. Okay, so we can connect to the single router's connection to the multiple machines. So automatically, the every host will get the internet by using the same link. Okay. So this is the difference between the routers and switch. Okay. So and coming to that, L3 switches. What is a layer 3 switches? Okay. So tomorrow we are going to see about this OSA layer and other things. Okay. So inside that, okay, what is the difference between normal switch and L3 switch? Okay. Have you heard about this layer 3 switch anywhere?
I know that layer 2 switches is there, layer 3 router is there, but there is something called layer 3 switch which I don't know.
Okay, so layer 3 switch is nothing but, okay, it's a combination of router and switch. Okay, so single device, in a single device. Okay, the we have some we have some advantages and disadvantages. Switches, we have some advantages and we have some disadvantages. Both have the different
So
features. Okay, what are
it is nothing but router itself. Then why are we calling it a switch? Because in router, if you give multiple ports, multiple RJ45 ports to connect to like multiple empty RJ45 ports, then it becomes a switch. So why is it called a layer 3 switch? Why not just layer 3 router with more switch,
yes,
more ports?
see, we have some features. Okay, so whatever we are going to learn in the unit 2 and unit 3 is a completely different. Okay, so in the unit 2 we are going to see some configuration called VLAN, okay, port channel, okay, and STP protocol. So this all something related to the only switches. Okay, we cannot configure those configuration in the routers.
Okay.
Okay, and the same like inside the routers we can enable the routing protocols and other features that is we cannot configure in the switches. Okay, but in the L3 switches, okay, you can say like a simple words. Okay, so if it's a routing is enabled and we have the n number of ports, that is also the routers with many ports. Okay, but not actually. So we can run the configuration wise the both configuration like a switches configurations as well as a routing configuration we can enable in the single device. So that is the difference. Okay. So we have some dedicated products called, okay, L3 switches is we have, but if you go for the Cisco, we have a dedicated products called Nexus. Okay.
Yes.
Inside the Nexus, we have a different models,
Data
NK,
center
Nexus 2K,
switches, right?
5K.
They
Yeah.
are like data center
Sorry?
switches. They are like data
Correct.
center
So
switches.
that correct. So that is a dedicated for data center
Yes,
devices.
yes, yes.
Okay. So these all have the n number of features we have. Okay. So that is the difference between the layer 2 and layer 3 switches. Okay.
Okay, okay.
So now, okay. So now we have a overview of these routers and switches. Then what is a firewall? Then what is called as a next generation firewall particularly? Any idea? Firewalls, you know, I know.
Uh,
Firewalls, you may know. But what is the difference between what is a next generation firewall?
I think firewall will just block based on some uh, in like I think next generation one is that which can block data based on multiple advanced settings than the current than some basic rules. So basically, I think it can block application wise. So for example, if we want to have a meeting over Zoom and we want to say block only audio but keep video, so I think with the advanced firewall configuration we can do that. Just so basically what is in my head is some advanced configurations if you want to do with regards to blocking, you should be able to do with next generation firewall.
Correct. So yeah, 50 percentage correct, I can say.
Okay.
See, so next generation firewall. So we have a multiple generations of firewall. For example, first generation firewall, then second, then third, then last four. And instead of fifth generation, we call it as a next generation firewall. That's all. Okay, we have a 5 generations of firewall.
Okay,
In the
so
first generation,
Gen 1, Gen 2, Gen 3, Gen 4, Gen 5, 5 generations.
correct. So instead of Gen 5, we call it as a next generation firewall. That's all.
Oh, okay.
So in Gen 1, okay, it's only for the packet filtering firewalls. Okay, for example, it will only filter the traffic based on the source IP address and destination IP address. Okay,
Okay.
if the source and destination is allowed, then it will allow the traffic, but it will not completely check the packet. For example, if I am the known user, okay, my IP is already allowed in the firewall, but if I send some virus file, okay, this firewall will not detect that and it will allow the traffic.
So
Okay,
basically, from
so
where the IP is coming, it will allow or disallow.
correct. So based on the IP address.
Okay.
Okay, so the second generation they will cover that particular things. Okay, they will so initially they will check the payload of the packet. So that is also having some issues. Then the third generation will come. So third generation also is having some loophole. Then fourth generation will come. So fourth generation also have some loophole. Then the fifth generation will come. Okay, so in the Gen 5 we have, as you said, there is we have a multiple advanced features. One is we call it as a deep packet inspection. So in this, all the four generation of firewalls, if the traffic is encrypted, okay, then the firewall should not able to read the packet payload of the packet. For example, it's a encrypted format. Okay, so that is in a secure packet. So, but in the next generation firewalls, it will decapsulate. So that means decrypt the packet and read the messages. If something is fishy, then it will block the traffic. Or if everything is okay, then again it is encrypt the traffic and then it will allow. So that is called a deep packet inspection. Number one. Okay, and we have other features like inbuilt antivirus, inbuilt URL filtering, that means a web filtering. So again, we have a multiple features. That's all subscription based.
So basically,
Okay.
if a packet is encrypted, um, next generation firewall can decrypt the packet and allow and disallow.
Correct.
Is that what we are saying here?
Correct. See,
But how
if
can
you are the source,
how can they
if you are the
decrypt? How
source,
can they decrypt? They don't have keys, right?
correct. So that is called a deep packet inspection. We that firewall will generate some called as a temporary key. Okay, by using that key, it will decrypt the packet. Okay, again it will encrypt the same thing. Then it will allow that. If you are, we'll see like in the fifth unit, we can see like what is a deep packet inspection and all everything. Okay, so that is the one features. Okay, same like we have a number of features inside the firewall. So this all comes under the subscription basis. Okay, instead of buying some hardware component and fixing binding into the firewalls, instead of that we can all get it from the subscription basis and inbuilt IPS and IDS. Everything is there. Okay, if you want, you will get the license. Okay, if you don't want, after that you don't want to renew the license, automatically that application, that means that the features will disable. That's all. So these are all the some basic things in the next generation firewall. Okay, so I will give you one task like so just Google it. What is happening in the first generation firewall? What is the issue? Then what is how it covered in the second generation? Then second generation, what we have what is the issue? Then third generation, then fourth, and then fifth generation. Just Google it. Okay, when you are free.
I'll do that. No worries.
Okay. So coming to that IPS, okay, okay. So from the IPS itself, we can finish it today class. So we have a firewall, right? So why we need the IPS? What is? Have you heard about this IPS and IDS anywhere?
IPS, you said?
Yes.
No.
Okay. Let me give you one example. Okay, I have a iPhone 17 Pro Max. Okay, so that will cost around like a 1,50,000 in Indian rupees, I can say. So in that particular iPhone 17 Max, okay, I am taking some pictures. Okay, and in my other hand, I have some Sony DSLR camera, like around 50,000 or 60,000 something. Okay, I'll take the picture on the DSLR as well. Which one should be better?
Well, because DSLR is a dedicated camera for taking photos, most likely in if the conditions are same, then DSLR will be better.
Yes, correct. Exactly, you are saying. So camera is dedicated for the only the photos, like all the sensors, all every single equipment is designed for the better photos. But iPhone 17 Pro Max is not like that. Okay, we can take the camera and we can make a calls and we can surf on the internet, etc., etc. There is so much product is there. The same like it's a firewall between the firewall and the IPS. Sorry, firewall, we have a number of features we have. Okay, that's not only for packet filtering. We can create a NAT configuration, VPN. Okay, so we can run the firewall as a router as well. Okay, so we have a n number of features inside the firewall. So packet filtering is there, but not
such to the extent level. Okay, but IPS, okay, we have a two device called one is IPS and one is IDS. Okay, the both devices are kind of same thing. I will give you the difference. So this two devices is dedicated for packet filtering. Okay, even though if something is missing in the firewall, this IPS IDS will detect that and it will block the traffic. Okay, it's dedicated for packet filtering. Okay, so whenever if you are using the IPS, we don't need a firewall. Not like that. We need a firewall. Okay, at the layer one.
This is also
In
a
the layer
firewall.
two,
Then. This is also a firewall then, right? Because it is also doing the job
no,
of
no,
filtering.
no. We cannot do that other configuration. See, firewall again. I am saying that firewall act as a router as well. Okay, we can run the router configuration in the firewall. We can build the VPN. We can create the NAT configuration. We can create the access rules. That's everything is not allowed in the IPS. Okay, only packet filtering is there. Okay, but in the supremacy level. Okay, so IPS is a different device, firewall is a different device. Okay, if such a source, I have some small company, okay, then maybe I don't need the IPS because I don't need a packet filtering at that level. Then I can only fix with the firewall. I am okay with the firewall itself. If the security is my most important thing, okay, I need a some extent level of security, then you can go for the firewall as a layer one, then layer two as a IPS. Okay, once some small bug or something is bypassing the firewall, okay, then it will land into that IPS and it will detect that and it will take an action. So this is the difference. Okay, so IPS is a such kind of devices. Okay, and what is IDS? There is a two differences here. Okay, IPS is a intrusion prevention system. Okay, IDS is a intrusion detection system. Okay, so both are working in the same procedure, but the action taken is different. IDS is only detect the malwares or the bugs or something, but it will allow the traffic inside to our data center, inside your LAN network, and then it will send you the notification. Okay, so I detected some bugs.
IPS is both detection as prevention.
Correct. So I'll detect something. Okay, I'll allow the traffic, but this is a notification I can give it. So IPS will block the traffic itself. Okay, if something is fishy, it will block the traffic. Then what is the purpose of the IDS here? That's a question, right? So IPS, it gives the both prevention. It will not allow the traffic at all. But why we need the IDS? For example, if you are my customer, okay, you are my customer, okay, we are doing some business. So for example, I can say, okay, so since you are using that Mustafa.com e-commerce platform, there is some company you are tie up with this payment app. Okay, once when customers is going for the payment, the another company will come to the play. Okay, so that company you are doing they are doing the some business. Okay, but they are not a technical person. For example, I'm saying they are not a technical persons. Okay, so they are trying to reach your data centers. Okay, there is some minor bug is there. Okay, so due to the minor bug, this IPS block the traffic. What will happen? They think like, okay, whenever I am accessing the Mustafa's application, it will not work. So that is affect our customer credibility. Okay, so that time if I have some trusted users, okay, that users will not purposely cause any damage to my systems, then that particular connection we can use the IDS. Okay, if I place IDS here, what will happen? IDS, then it will allow the traffic, so customer will get that application and no issues on that. Then we can contact as a Mustafa, your network engineer need to contact them. Hey, so you are using this application and this communication, right? So this is having some minor bug. So due to this can cause a damage. So you need to fix that. So customer will happy. Okay, I'll fix that, no problem. So he will fix the problem. So that particular time you need a IDS. Okay, no, my prevention, that means the security is at most priority, then you can use a IPS. I don't want to allow a single minor bug into my data center, into my LAN communication, you need to use a IPS. Or else, if there isn't any trusted customer, okay, so then you can use the IDS. So this is the difference. You get my points?
Yeah, so basically, if someone is a bit trusted, we don't need that much security, then we
Security,
will choose IDS.
correct.
Okay. Is the cost the factor in that, or trust
Yeah,
the factor?
cost is also that. But now I am saying 99.9% they are using the IPS only. Okay, because everyone is doing that technical that means a digital oriented business. They need a security, and then also now we have a complete awareness of the what is there and what is not there. So everyone is using the IPS only. Okay, 99.9%.
Okay.
Okay, but the difference is here. Okay, here only we have IPS only, we don't have IDS. Just I'll tell you the example. What is the difference? That's all.
Okay.
And we can expect the interview question as well. What is the difference between IPS and IDS?
Oh, okay. All right. I have to join another class actually. It's time is up.
Yeah. Carry on. We'll meet tomorrow.
What about the class notes? The something?
Okay, I'll have a complete entire one first unit notes. I will send to you. You can have a look.
Okay. All right. We'll meet
Okay.
tomorrow again then for the same time, right?
Yeah, same time.
Okay. All right, Ishwara. Thank you.
Okay, bye.
Okay. Bye.